A warm good morning to all. In this lecture, I will discuss the solution of JAM exam in physics in the year 2022. As we all know, it is a competitive exam. Based on the score of this exam, students can get admission to IITs, NITs, etc. This exam has a total of 60 questions and 5 sections. In section A, there are 10 questions. Each one carries 1 mark. And the first question is the equation z square plus z bar square equal to 4 in the complex plane, where z bar is the complex conjugate of z, represents. So an equation in the complex plane represents what? That is the question. So we can represent a complex plane like this. It's actually a two-dimensional plane with the real part on horizontal axis and the imaginary part on the vertical axis. And any point on this plane, we can represent it by the letter z, and it is usually x plus iy. We can denote it as x plus iy, or equivalently an ordered pair of x comma y. This is the representation of a point in the complex plane. And what is the meaning of complex conjugate? Complex conjugate is nothing but the mirror reflection of that point about the horizontal axis. That is, you will get a point on here, and z bar is the x value is same but y value is negative, so it is x minus iy, or it is x minus y. That is the meaning of conjugate. And now we have to calculate what is z square. What is z square? X plus iy the whole square, and it is x square plus I into 2xy minus y square. What is z bar square? It is x minus iy the whole square. It is x square minus 2i xy minus y square. Okay, so this is a plus b the whole square equation. This is a minus b the whole square. Okay, and here we used the identity I square is minus 1. Okay, I square is minus 1. That is the definition of I. Okay, now we have to substitute back in this expression. That will give x square plus I into 2xy minus y square plus x square minus 2i into xy minus y square equal to 4. This I into 2xy will cancel, so the minus I into 2xy. Remaining thing is x square minus y square is equal to 2. Actually, there are 2x square and 2y square. Cancelling the 2, you will get x square minus y square is equal to 2. This is an equation of hyperbola. X square by 2 minus y square by 2 is equal to 1. Equation of hyperbola. I will plot a hyperbola for you. The equation was x square by 2 minus y square by 2 equal to 1. And this is the figure of the hyperbola. So the answer is option B. Answer is option B. Okay, you will get 1 mark for this question if the answer is correct. Moving over to the next question. and it is a question from special theory of relativity. A rocket moves at a speed c by 2 along the positive x-axis, where c is the speed of light. When it crosses the origin, the clocks attached to the rocket and the one with the stationary observer located at x equal to 0 are both set to 0. If s observes, s means the stationary observer located at x equal to 0, observes an event at xt, the same event occurs in the frame s prime. S prime is the rocket frame. Okay, so we have basically two frames, and let me draw the x-axis like this. Okay, this is my x-axis, and if there are only one axis, we can mark the origin arbitrarily. Suppose the origin is somewhere here. We have two frames. One is S, and the S frame is stationary at the origin. Okay, so this is x-axis, this is y-axis, this is z-axis as per my drawing. This is the frame S, and a frame is attached to rocket. Frame is attached to rocket, and rocket is moving parallel to x-axis. So this is the frame attached to the rocket. This is y prime axis, this is z prime axis, this is x prime axis. So this is frame S prime, and this frame is moving with a velocity c by 2. Okay, that's also given. This frame is moving with velocity c by 2. We can apply Lorentz transformation equations. What are Lorentz transformation equations? These are transformation equations connecting the coordinates of two events in two frames which are in relative motion with uniform velocity. So x prime is equal to gamma into x minus vt. This is one of the equation if the motions are parallel to x-axis. Y prime is equal to y, z prime is equal to z, and t prime is equal to gamma t minus vx by c square. These are the Lorentz transformation equations. I think you are all familiar with this. Here gamma is 1 by root of 1 minus v square by c square. In our case, v is c by 2, so that becomes 1 minus 1 by 4, and it is 2 by root 3. This is the value of gamma. Okay, and v, of course, it is c by 2. So substituting that values, we will get x prime is equal to 2 by root 3 x minus ct by 2. Y prime is, of course, y, z prime is z, t prime is 2 by root 3 t minus x by 2c. This is the correct answer, and from the choice we can see that option A is the correct one. Okay, so this is a question from special theory of relativity, and if you know the Lorentz transformation equation, you can easily write the answer. Moving over to the next question, question number 3. It is a question from statistical mechanics. Consider a classical ideal gas of n molecules in equilibrium at temperature T. Each molecule has two energy levels, minus epsilon and plus epsilon. The mean energy of the gas is. Okay, so the question is to find the mean energy of classical ideal gas, and each molecule can have two energy levels. Okay, either minus epsilon or plus epsilon. Okay, so average energy E bar is sigma I Pi Ei. Here I can take values 1 and 2. So we can write E bar is equal to P1 minus epsilon, because the first possible energy is minus epsilon and the second possible energy is plus epsilon, P2 epsilon. Now what are the probabilities? Probability of a particular energy level Pi is the Boltzmann factor e raised to minus beta Ei divided by partition function. What is partition function? Partition function is sum over all states, the Boltzmann factor. Therefore, I can find P1 as e raised to minus beta into minus epsilon divided by e raised to minus beta into minus epsilon plus e raised to minus beta into epsilon, sum over all the energy states. So this is e raised to beta epsilon divided by e raised to beta epsilon plus e raised to minus beta epsilon. Similarly, P2 is e raised to minus beta epsilon divided by, denominator will be the same, sum over all energy states. Okay, so we obtained P1 and P2. Substituting back, we can calculate average energy E bar as e raised to beta epsilon into minus epsilon divided by e raised to beta epsilon plus e raised to minus beta epsilon plus e raised to minus beta epsilon into epsilon divided by e raised to beta epsilon plus e raised to minus beta epsilon. You can take epsilon outside, minus epsilon outside, so that becomes minus epsilon into e raised to beta epsilon minus e raised to minus beta epsilon divided by e raised to beta epsilon plus e raised to minus beta epsilon. And the term inside bracket is nothing but tan h beta epsilon, and beta is nothing but 1 by kt, 1 by kt, that is the relation between beta and Boltzmann constant. So it is minus epsilon bar tan h epsilon by kt. And the entire calculation is for one particle, and the internal energy or mean energy is an extensive property. If there are n molecules, then the average energy will be minus n epsilon tan h epsilon by kt. By mistake I put a bar here, there is no need of this bar. This is average energy E bar, and that is given by minus n epsilon tan h epsilon by kt. The correct answer is option C. Option C. Okay. Moving over to the next question. It's a question from thermodynamics. At a temperature T, let beta and K denote the volume expansivity and isothermal compressibility of a gas respectively. Then beta by K is equal to. Okay. And in answers, we have dou P by dou T at a constant V, dou P by dou capital V at constant T, dou T by dou P at constant small v, dou T by dou capital V at constant P. And we have the definition, small v is equal to volume per mass. Okay, capital V is the volume, total volume, divided by mass. Volume per mass is known as or denoted by small v. And actually small v is a function of pressure and temperature. Therefore, the perfect differential dV, we can write it as dou V by dou P at a constant t into dp plus dou v by dou t at a constant p into dt. If we divide throughout with a small v, this becomes 1 by v dou v by dou t at a constant p dt plus 1 by v dou v by dou p at a constant t dp. Again, dv by v is equal to, I will put this quantity 1 by v dou v by dou t at a constant p inside a curly bracket into dt, and I will take a negative sign outside, then minus 1 by v dou v by dou p at a constant t inside curly bracket into dp. The term inside first curly bracket, this is nothing but volume expansivity, beta, volume expansivity. And the term inside the second curly bracket, this is nothing but K, and it is isothermal compressibility, because this is at a constant temperature, isothermal compressibility. So these are the definition of beta and K. Therefore, I can write dV by V is equal to beta dt minus K dP. At a constant V, LHS becomes 0, that is beta dt equal to K dP, or beta by K is dou P by dou T at a constant V. At a constant V. So this is the expression for beta by K. So the correct option is option A. Option A. Moving on to the fifth question. It is the subtraction of two binary numbers 1110101 and 001110. I think one of the easiest method is convert them to decimal numbers, then subtract two decimal numbers. Okay, so here we have 7 digits, so this will be 2 raised to 6, 64. The next number will be 2 raised to 5, 32, then 16, 8, this is having weight 4, this is 2, this is 1. And by adding the numbers with the digit 1, that is 64, 32, 16, 4 and 1, you will get 117. Okay, the answer is 117. Again, the next number 001110. The first position 64, then 32, then 16, then 8, 4, 2, 1. And the non-zero numbers 16, 8, 4, 2. It is 30. So subtracting these two numbers, 117 minus 30, answer is 87. And the corresponding binary number you can calculate using this method: 2, 4, 3, then 2, 2, 1, then 2, 10, 2, 5, 0, 2, 2, 1, 2, 1, 0. Taking it in the reverse order, the answer is 87. 10. Binary equivalent is 101011. The correct option is option B. Or we can do this in binary form itself. This is the first number. The second number is 001110. when you subtract these two numbers, 1 minus 0, it is 1. 0 minus 1, it is not possible to subtract 1 from 0, so you have to take a borrow. So this becomes 1 0. 1 0 minus 1 is actually 1. Now here you have 0. So this becomes 0. Again you have to take a borrow from here, but here it is 0. It is not possible to take a borrow from that. So when you take 1 from here, this becomes 1 0, and from here you take a 1. So that becomes 1 0. 1 0 minus 1, you will get 1. Here from 1 0, a 1 is goes there. So remaining will be 1 0 minus 1, it is 1. 1 minus 1, answer is 0. From here, this 1 go to this side. The remaining is 0. Again, you can take a borrow from here. That makes it 1 0. 1 0 minus 1 is 1. Here it is 0. 0 minus 0 is 0. 1 minus 0 is 1. Again, the answer is 1 0 1 0 1 1 1. So either you can do this way, but this is a little bit confusing. So you can convert them to by decimal equivalents, then subtract decimal numbers. Okay, the correct answer is option B. Moving over to the next question. It is a question from quantum mechanics. Consider a particle trapped in a three-dimensional potential well such that u is 0 for x between 0 and a, y between 0 and a, z between 0 and a, and u is infinity everywhere else. That is, it is a three-dimensional potential well. Three-dimensional potential well. Due to the boundary conditions, energy is quantized and it is proportional to three quantum numbers, nx square plus ny square plus nz square. Okay, nx, ny, nz are three quantum numbers, and they obtained due to these boundary conditions along x, y and z directions. This nx, ny, nz can take only integer values 1, 2, 3, etc. So the lowest value of nx, ny, nz are 1. So ground state, I can say that ground state is the one with nx1, ny1 and nz1. And then energy will be proportional to 3, and it is a non-degenerate state. What is the meaning of degeneracy? Degeneracy is the number of states which are having the same energy value. For energy proportional to 3, there is only one state. That is the meaning of non-degenerate state. The proportionality constant is irrelevant. In order to find the degeneracy, we just wanted to know this dependence. Now, the first excited state. What about first excited state? Any of the nx, ny or nz becomes 2. So I can have three possibilities, either 2 1 1 or 1 2 1 or 1 1 2. All this energy proportional to 6. That is the next possibility. And degeneracy is 3. Degeneracy is 3. Second excited state, again one more quantum number becomes 2. That is 2 2 1. That can be written as 1 2 2 or 2 1 2. Again there are three possibilities. E is proportional to 9. Degeneracy is 3. Then third excited state, that can be all these quantum numbers 2, then the total energy proportional to 12, but be cautious, we can consider this possibility, 3 1 1. It can be like 1 1 3 or 1 3 1. Then energy will be proportional to 11. So this has energy less than the case with the nx equal to 2, ny equal to 2, nz equal to 2. Okay, so that will be the fourth excited state. Fourth excited state will be all the quantum numbers are 2. In this case, degeneracy, in the first case degeneracy is 3, but Here E proportional to 12 and it is a non-degenerate state. Only one possibility. So it is a non-degenerate state. What about the fifth excited state? What is the next possibility? It is simply 312. 312. So energy will be proportional to 14. What is the degeneracy? It can be 312 or it can be 321 or it can be 123 or it can be 132 or it can be 213 or it can be 231. So degeneracy is 6. All those corresponds to energy proportional to 40. So the degeneracy is 6 for the fifth excited state. The correct option is option C. Moving on to the next question. Question number 7. A particle of mass m and angular momentum L moves in space where its potential energy is u of r equal to kr square, where r is the radial coordinate. If the particle moves in a circular orbit, then the radius of the orbit is. Here the potential energy is given as u of r is equal to kr square and it is a central force problem. This potential depends only on radial coordinate. Then we can define an effective potential V effective, and that is always the sum of L square by 2m r square and the given potential. Here it is kr square. This L is angular momentum. Here it is given as capital letter L. So I will substitute it as capital L. L square by 2m r square plus kr square is the effective potential. The condition for circular orbit is given by dV effective divided by dr at r is equal to r naught. If r naught is the radius of circular orbit, then the condition is first derivative should vanish. That is, if we plot V effective versus R, there should be a minima or maxima for existence of a circular orbit. That is the condition. So if I take the derivative of L square by 2m r square plus kr square and then put r is equal to r naught, we should get 0. The first term L square by 2m is constant. 1 by r square derivative is minus 2 by r cube. By putting r equal to r naught, you will get minus 2 by r0 cube. The second term, it is 2k r0 equal to 0. This negative term you can take the right hand side. So 2k r0 is equal to L square by m r0 cube. That implies r0 raised to 4 equal to L square by 2mk and r0 is L square by 2mk whole raised to 1 by 4. The correct option is L square by 2mk the whole raised to 1 by 4. Answer is option B. Option B. I hope it is clear. For a central force problem, if the potential will be a function of radial coordinate only, then the next step is writing effective potential, that is always the given potential plus L square by 2m r square. Then for a circular orbit, this effective potential should have a minimum or maximum, and for stable circle it should be a minimum. Okay, and in order to find the position of minima, the first derivative should be 0, and by applying that condition, the radius of circular orbit will be L square by 2mk raised to 1 by 4. Or to the next question, consider a two-dimensional force field Fxy equal to 5x square plus ay square plus bxy x cap plus 4x square plus 4xy plus y square y cap. If the force field is conservative, value of A and B. If a force field F equal to Fx I cap plus Fy j cap plus Fz k cap is conservative, that means del cross f is 0. Del cross f is 0. So here we can calculate del cross the given vector field. What is del cross f? It is I cap, j cap, k cap, dou by dou x, dou by dou by, dou by dou z, and the first component of f, here it is 5x square plus ay square plus bxy. Second component 4x square plus 4xy plus y square. Third component, it is 0. This determinant should be 0. That is the condition for f conservative. Then I can write it as k cap into, because the other two becomes 0, I cap into dou by dou y of 0 and dou by dou z of this quantity is 0. J cap into, again that will give you 0. Then k cap into dou by dou x of 4x square, and that will be 8x plus 4y minus dou by dou y of, that thing is minus 2ay minus bx, derivative with respect to y, and this should be 0. That is 8x minus bx plus 4y minus 2ay equal to 0, or 8 minus b into x plus 2 into 2y minus 2a, now 2y minus ay equal to 0, or 8 minus b into x plus 2y into 2 minus a equal to 0. This implies b equal to 8, a equal to 2. Correct option is a equal to 2, b equal to 8, option B. Option B. Over to the next question. Consider an electrostatic field E in a region of space. Identify the incorrect statement. What is the meaning of an electrostatic field? Electrostatic field. Electrostatic field means if you have 2 points in space, say A and B, and suppose you are taking a charge Q from A to B through this path. There is a uniform electric field in this region. Suppose it is E. Then the work done against this field in moving the charge from A to B is given by dW is equal to integral A to B E dot dr, where dr is an infinitesimal line element along this curve. If this E can be written as the gradient of a scalar is equal to minus del V, then this dW becomes integral A to B minus del V dot dr. What is the definition of del V? I cap dou by dou x of V plus j cap dou by dou y of V plus k cap dou by dou z of V. That is del V. What is dr? Dr is a line element. It is dx I cap, dy j cap, dz k cap. Therefore, del V dot dr is nothing but dou V by dou x dx plus dou V by dou y dy plus dou V by dou z dz, and it is dV. Therefore, this dW is minus integral A to B dV, and it is nothing but V evaluated at A minus V evaluated at B. Therefore, the work done depends only on endpoints. Work done depends only on endpoints. If A equal to B, that is if it is a round trip, okay, the particle goes from A to B and then returned to A. The endpoint, starting point and endpoint are the same. Then closed integral E dot dr, that is the work done, and that becomes 0 because the work depends only on the endpoints. Work depends only on the endpoints and the endpoints are the same. A and B are the same for a round trip. So closed integral E dot dr equal to 0 for a electrostatic field. Okay. So the first option, look at the first option. The work done in moving a charge in a closed path inside the region is 0. That is correct. Curl of E is 0. We know that for an electrostatic field, E is equal to minus del V. And what about del cross E? Del cross E is del cross minus del V, and it is minus of del cross del V. Curl of gradient is always 0. Curl of gradient is always 0. That is the standard identity. Curl of gradient is always 0. So for an electrostatic field, the curl of E is 0. That is correct option. This is correct. The field can be expressed as gradient of a scalar potential. That is also correct. So identify the incorrect statement, means the incorrect statement will be the potential difference between any 2 points in the region is always 0. Moving on to the next question. This is regarding the intensity distribution of diffraction pattern from a single slit. Which one of the following figures correctly depicts the intensity distribution for Fraunhofer diffraction due to a single slit? Here x denotes the distance from the center of the central fringe and I denotes the intensity. Okay, this is the question. So we all know the intensity I is equal to I0 sine square beta divided by beta square. This is the intensity distribution of a single slit diffraction pattern. What is beta here? Beta is pi a sine theta divided by lambda. A is slit width. A is slit width. Lambda is wavelength of light. Lambda is wavelength. Okay. What is sine theta? If the distance from the center to the outward direction on either side is denoted as x, then sine theta is approximately x divided by d, where d is the distance between slit and screen. Distance between slit and screen. Okay. So in terms of x, I can write intensity I as some constant into sine square pi a x divided by lambda d divided by pi a x divided by lambda d the whole square. We can denote all the terms along with the x as some constant, say alpha. So it is sine square alpha x divided by alpha x the whole square. This is the equation for intensity. And what is the plot of this function? I will plot the function for you. Let me take the value of I0 as say 2, then 2 into sine alpha x. Sine, let me take alpha as 1, so sine 1x divided by 1x the whole square. Okay. I0 sine alpha x divided by alpha x the whole square. This is the graph. I can modify the axis x from 0 to say 2.7, y from 0 to 2.7, x from say minus 10 to 10, then the graph will look like this. Okay, so a central maximum, then followed by secondary maxima and minima. The correct option is option C. The correct option is option C. This is the intensity distribution due to a single slit diffraction. Okay, thank you. So we completed the first 10 questions, section A. In the next lecture, I will cover section B. Okay, thank you.